Next, to factor a perfect square trinomial, just find the square root of the first term and the square root of the third term and just write it in the form square of the sum or difference of two terms. Okay, example, m squared plus 14mn plus 49n squared. Since this is a perfect square trinomial, its factors are m plus 7 and quantity squared. So that is the square root of m squared, or the square root of first term. So that is m, and the square root of the last term, which is 49n squared, is 7n. Next example, we have 9u raised to 4 minus 30u squared v plus 25v squared. So again, find the square root of the first term. So that will give us 3u squared, and the square root of the last term, that is 5v. And for the last example, we have c plus d squared minus 16 times c plus d plus 64. So since it's a perfect square trinomial, we have to find the square root of the first term. Square root of c plus d squared is c plus d, and then the square root of 64 is 8. For its answer, we have c plus d minus 8 quantity squared. Next is factoring by grouping. To factor polynomials by grouping, we're going to group the terms with a common monomial factor. In the example, un plus vm plus vn, we can group and un and vm plus vn. And then after that, we have to take out the common factor, which in this group, in the first group, is u, and the common factor for the second group is v. So that's why we'll have u multiplied to m plus n plus v times m plus n. And then after that, we have to factor out the common binomial, which is m plus n, and the other factor is u plus v. Since we factored out the common binomial, so what will be left inside are u and v. So that's why we have u plus v. We have an alternative solution. We can group um and vm and un and vn. And in the first group, the common monomial factor, or the common factor, is m. And in the second group, the common factor is n. So we're just going to take it out. And then after that, we have to take out the common binomial, which is u plus v. So it's common on the first term and the second term. U plus v is present, so we'll take out the common binomial, u plus v, and what will be left inside, or the other factor, will be m plus n. So as you can see, they are just the same. Another example of factoring by grouping, given z cubed minus z squared minus z plus 1, we're going to group z cubed and z squared and z and 1. So as you can see, we already changed the sign in z plus 1. It's because we have a subtraction operation here. So that's why we have z minus 1 instead of negative z plus 1. Then after that, we have to take out the common factor. In z cubed minus z squared, the common factor is z squared. And what will be left inside is z minus 1. And since in z minus 1, there's no common factor, so just copy it. After that, we have to take out the common binomial factor. Taking out z minus 1, what will be left inside is z squared and 1. Z squared minus 1, as you can see, can still be factored by using the difference of 2 squared. So just copy z minus 1, and by factoring out z squared minus 1, we're going to have z minus 1 times z plus 1. Again, what did we use? The difference of 2 squares. Okay, by simplifying, the final answer will be z minus 1 squared times z plus 1. And we also have an alternative solution for this example. And in this solution, we're going to group z cubed and z squared and 1. And please try it on your own, and you'll see that you're going to arrive at the same answer as well. Last is about factoring quadratic trinomials. Examples, we have x squared plus 5x plus 6. And to find the factors of this trinomial, notice that the leading coefficient is 1. And if the leading coefficient is 1, we have to find the factors of the first and third term first. The first term x squared, its factors are x and x, since x times x will give us x squared. And for the third term, we should find also its factors, but before that, we should think of two numbers that will give us a product of 6 and the sum of 5, which is the middle term. And those numbers are 2 and 3. So when we multiply 2 and 3, that will give us 6. And when we add 2 and 3, that will give us 5. So that's how you find the factors if the leading coefficient of the given quadratic trinomial is 1. To check if your factors are correct, you can do the FOIL method. Next example, we have 2x squared plus 13x plus 15. So as you can see, the leading coefficient is 2. So what are we going to do is to multiply the first and last term. So that is 2 and 15, and 2 times 15 will give us 30. And now we need to find the numbers that when we multiply will give us 30, and then when we add will give us 13 here. Okay. So what do you think are those numbers? Okay, so that will be 10 and 3. 10 times 3 will give you 30, and 10 plus 3 will give you 13. What we're going to do is we're going to replace the middle term by 10 and 3. So that will be, just copy 2x squared. Then instead of 13x, we're going to write 10x plus 3x, and then just copy plus 50. Then after that, we are going to factor by grouping. So first two terms, let's group 2x squared and 10x and 3x and 15. In the first two terms, we'll take out the greatest common factor, which is 2x. So what will be left inside is x plus 5. And in the second group, we have 3x plus 15. By taking out the greatest common factor, that is 3. So that will give us 3 times x plus 5. And just like what we did earlier in factoring by grouping, so we'll take out the common binomial, so in which in this example is x plus 5, and we'll write the other factor, which is 2x plus 3. So the factors of 2x squared plus 13x plus 15 are x plus 5 and 2x plus 3. Okay, I want you guys to try these examples, factoring by grouping and factoring quadratic trinomials, and we'll reveal the answer on our next online meeting. Thank you guys for listening, and we hope that you learned.